Well, for those of you thinking about gene editing, that was an inspiring, depressing, and ornate history. Thanks so much for going through that with us. Our next speaker, and what I decided to do just in the interest of time here to keep us a little bit more on time, is Alan Blake of Yorktown Technologies. All the bios are in your handout stuff, so instead of trying to read them to you, just look them out. Alan has been working with various animals for some time, but the GloFish is the one that has some notoriety, and he's going to lead off with that in terms of ethical considerations related to the first widely available biotech animal, of which I can say I owned one for a short period of time before it demised.
Good morning, everyone. Dr. Kaplan, thank you for the introduction. Thank you for your support. As a GloFish owner, I'm happy to say that GloFish are widely available and easy to replace, so thank you. I appreciate the opportunity to be here this morning to share our experience with GloFish. I want to thank the organizing committee for inviting me. As many of you know, in late 2003, we brought GloFish to market as the first widely available biotech animal. This was received with a mixture of excitement, fascination, fear, and anxiety. As just one example, a New York Times article heralded the arrival of GloFish as the start of the new era of biotechnology, while simultaneously a different front page article in the Times suggested that this could cause substantial ecological trouble. Meanwhile, an activist group sued the FDA in federal court, claiming that they were aesthetically, physically, and recreationally injured by the availability of GloFish, insisting that our fish would set a dangerous precedent, opening the floodgates for all manner of genetically engineered animals, a claim that would be repeated with no sense of irony more than an entire decade later when the FDA recently announced its approval for the Aqua Bounty salmon. Back in 2003, when our fish first became available, it was still more than 5 years before the FDA would release their formal guidance related to the regulatory pathway for genetically engineered animals. And we stood as the only company to market such an animal to the public, a position that we continue to hold to this day. Thankfully, we did not stand alone, and we found many great researchers and experts who were able to help us chart a positive and ethical path forward. With their help, we had undertaken a 2.5-year ecological and ethics assessment before commercializing our fish, which I'll discuss further in a few minutes. So my goal today is to share our experience and the way that we approach the ethical complexities associated with GloFish. My hope in doing so is to better inform the discussion to help bridge the gap between industry and other stakeholders in this vitally important matter. With that said, I'd like to start by sharing a little bit about GloFish. So, as I mentioned, GloFish are the first widely available biotech animal. They are tropical aquarium fish that express fluorescent proteins. They're available in 3 species and 12 lines. The first line of GloFish was developed by Zhu Yanggang at the National University of Singapore. The long-term idea was to use the fish to detect water toxins. So the first step was to make fish that fluoresced all the time. The next step they had conceived of would be to make fish that would selectively fluoresce in the presence of toxins. So sort of like you'd want to invent a light bulb before you invent a switch. These were the proof of concept fish. And each line has been reviewed by FDA as described in Guidance 187. I want to say that again because it has unfortunately been widely misunderstood. Every single line of GloFish that has been commercialized has been reviewed by FDA as described in Guidance 187. So here are our fish. We have, as I mentioned, 3 species, 12 lines. These fish are, as we like to say, born brilliant. They're born with their fluorescent color. They maintain it throughout their entire lives, and then they pass it on to their offspring through traditional breeding. And that's important to us that unlike dyed or injected fish, which are individually injected with paints and dyes. Unlike those fish, our fish have the color born with it through their entire lives. It's important to us, and that's important to our consumers. So what I'd like to do now is walk through, kind of go back in time, and walk through when we started this all the way back in about 2001, what were the pre-market ethical considerations that we examined before bringing GloFish to the public, to help give you an idea of the things that we considered. So things like, would there be any ecological consequences to marketing GloFish? Would there be any fish health or well-being impact? Are there any human health concerns? Is the technology used within accepted norms? What potential benefits could exist for humans and for fish in marketing GloFish? And more broadly, because we were the first company to try to do something like this, we wanted to really explore whether marketing GloFish would set a good example for the use of biotechnology with the public, with our industry, with the media, as well as scientific, regulatory, and business stakeholders. So first, I'll talk a little bit about the ecological safety review. So wild-type zebrafish had at the time been sold in the United States for nearly 100 years without any incident. Millions of wild-type zebrafish, millions sold every year for nearly 100 years without any incident. And based on the U.S. Geological Survey records, zebrafish have been, and to this day, have been unable to establish self-sustaining populations anywhere in North America. And that's despite being sold for over 100 years at millions of fish per year. So we then wanted to look at what would be the difference between those wild-type fish that had failed to establish or cause any incident whatsoever with our fluorescent fish. And we chose to use the net fitness model, which was pioneered by Muir and Howard. The net fitness model looks at different ecological fitness characteristics that are caused by the modification and analyzes that to determine what would be the ecological impact. And what we found as analyzing the fish is that fluorescent fish are slightly less ecologically fit than wild type. So they are just as hardy in an aquarium, but in an ecological sense, they are slightly less fit, primarily due to reproductive success shortfall, which I'll talk about a little bit later. So just as hardy in an aquarium, but not quite so fit ecologically. We then expanded from an internal analysis to discussions with leading experts in the field. So Bill Muir, who developed this model, Eric Hallerman at Virginia Tech, Allison Van Eenenaam. We wanted to talk with everyone who was an expert in the field and try to understand what were the potential consequences. And we then expanded to include state agency officials at wildlife agencies to try to get their perspective on this, particularly focusing on southern states, California, Florida, even Hawaii. And this ultimately led to the establishment of a formal scientific advisory board to help us chart a, again, good and ethical path forward, understanding all of the issues that we would be facing. And ultimately, we concluded, with the help of all of these great people, that there really was a broad consensus that there would be no ecological risk from marketing GloFish, and that this extended not only to where we would be marketing GloFish here in the United States, but even to areas where the fish were native, that because of that slight reduction in ecological fitness, even if the fish ended up where they were native, where the species were native, that the fluorescence gene would be eliminated from the population over time. So the next area that I'd like to discuss is fish health and well-being. This obviously is extremely important to us. And what we found there is that the fluorescence gene and the trait, the fluorescence trait, caused no discernible health or well-being impact on the fish. And we were able to conclude that because fluorescent fish had very long been used in scientific research. And it was known and widely accepted that their general behavior was unchanged. And that fluorescent fish, as a group, exhibit no unique signs of stress relative to their non-fluorescent counterparts, whether in terms of behavior or with respect to increased mortality and disease, both of which one would expect to dramatically increase if the fish were, in fact, experiencing stress. So we can't, of course, ask the fish if they experience stress, but we can look for the signs that would be likely if they were, in fact, experiencing stress and the signs were not there. More generally, the life cycle, including things like life expectancy, were unchanged in fluorescent fish. And very broadly speaking, fluorescent fish live a fish's life. They swim, they eat, they school, and they do the types of things that fish do in the same way that their non-fluorescent counterparts do. And this is not particularly unexpected because fluorescence genes are naturally derived. They're widely understood to be non-toxic, and for that reason, they have been widely used as marker genes in scientific research and had for a very long time when we were starting this initiative. And they are extremely common in marine organisms. In fact, the fluorescence genes in our fish come from marine organisms, from sea coral in particular. And more recently, the American Museum of Natural History discovered more than 180 species of naturally occurring fluorescent fish, which was actually very exciting. So then, of course, we wanted to look at human health considerations. So as I mentioned, the added protein is not toxic, and we found that it was not allergenic based on a screen against a database called AllerMatch, which is a database used to search for allergenicity potential. Of course, we're talking about aquarium fish, so there would be minimal direct human interaction. Our fish are not intended for use as food, so they would not pose a risk to the food supply. And in a general sense, the modification poses no known human health risks. So we also wanted to look at, was the use of this technology within existing norms? So as I've touched on a bit here, the creation of fluorescent fish was at the time already commonplace. They were developed in our case with the idea of detecting water pollution. They'd been used for developmental modeling. We saw a little bit about that yesterday in one of the presentations. They have been used for cancer research, and they have been, had been used for ecological risk assessment. We also took a very hard look at this question as to whether this perceived entertainment use could be inherently problematic from an ethical perspective. And at the time, we were dealing with a line that already existed. So we were simply going to breed already existing fish, and the fish were developed with a good and beneficial purpose. So from that perspective, that question didn't apply quite as much as had we been making the fish from sort of scratch. But even in that sense, and even for fish that were developed in the future, I think that question, as we looked at it, ignores the potential benefits of having the fish, including dismissing owners' fulfillment from the fish. And we also have, as Allison touched on in her presentation, a very long history of companion animal ownership. And so I think as a society, our perspective at the time was that, well, we've already long since crossed this bridge of keeping and selectively breeding animals for companionship. So on to potential benefits. We thought that this was a great way to support a positive use of biotechnology, that the proceeds from the sales of our fish would help to support the research at the National University of Singapore. And to this day, every time someone buys a GloFish, that helps to support the research at the National University of Singapore. And that commercializing the byproducts of scientific research in general does help to make that research viable. And so we thought that was an important benefit. We also thought that this was, if we did this in the right way and considered all the appropriate issues surrounding the commercialization of the fish, we thought that this could be a good test case for biotechnology, that we could show that in the right instance, when done in the right way, the public could accept biotechnology, and that was necessary for continued development of the technology to help facilitate the conversation and development of all the great applications we've been hearing about during this conference. We also hoped that marketing of our fish would reduce the demand for dyed and injected fish. This is an extremely controversial process where the live fish are injected with paints and dyes, and as you can imagine, there are substantial animal welfare concerns with this process. We thought this would be great from an educational perspective to develop complementary GloFish lesson plans, exploring the merits, ethics, and responsibilities of biotechnology. Also, with respect to companionship and emotional tranquility, Owning aquarium fish is a great way to connect to nature, to teach responsibility and care, and supports well-being through stress reduction. It's a widely known benefit that keeping aquarium fish help people who own those aquariums to experience less stress, which we all think is a good thing. As well as supporting the industry, helping to create jobs and economic opportunities, which benefits the tax base, supporting local government. And we hope that in the long term, with our success, that we would be able to support additional charitable initiatives. And so we also recognize that achieving these benefits would require a long-term ethical commitment, which we shared on our website through our guiding ethical principles on the day that our fish became available. So we recognized in sum that this technology was incredibly powerful and that using it carried with it a very significant responsibility, and we dedicated ourselves to these principles. Environmental safety first, so making sure that any line of fish that we marketed would be safe for the environment. Humane treatment of fish, very important to us. Our commitment to ensure that people understand, as Dr. Kaplan pointed out, these are living, breathing beings and that they need to be taken care of with the utmost consideration. Advancing scientific research. We wanted to put a good foot forward for the technology that brought GloFish to us, to the world, and we wanted to be able to advance the conversation and advance the research with what we were doing. And having an open and informed discussion. Again, part of why we did this, we thought this would be a great test case to let people explore the implications and the issues surrounding biotechnology. And part of the reason I'm really happy to be here today is just in the spirit of this open and informed discussion. So the initial reception. When word of our fish got to the market, there was a tremendous worldwide media response. So we had about 750 million media impressions. That would be the number of times someone would see, hear, or read about GloFish. Generally, very well received across the marketplace. In fact, 90% of our emails were unrelated to the biotech nature of the fish. So general fish husbandry questions, is my fish pregnant? What should I feed my fish? And lots of purchase questions. Where can I buy these fish? These seem really exciting. I want to get some. The FDA issued a statement that was consistent with our internal and scientific advisory board risk assessment, which unfortunately was widely misinterpreted and misreported to suggest that the FDA did not review our fish or did not have jurisdiction with respect to aquarium fish. We did our best to correct this, but like many other things, we found that unfortunately, media reports often ignored or confused easily accessible information. So things that were right there on our website, easily confused or otherwise just ignored. And there was the activist group that sued the FDA in federal court. So not long after our fish were on the market, additional state agencies reached formal safety findings consistent with the FDA, consistent with our scientific advisory board, consistent with our internal assessment, including California and Florida, southern states that have a lot of experience with fish. So there was really, what emerged was a unanimous consensus from qualified experts regarding the ecological safety of our fish. The activist lawsuit was dismissed on summary judgment, and the market interest was tremendous, but the demand was relatively low due to perceived weak color. Revisiting our pre-market assessment with the latest information, assessments now from the broader global scientific community, there really was no material change that suggested developing new lines of fish would be inconsistent with our original conclusion. So we started developing new lines of fish. Here we are 12 years later. Many additional GloFish lines are available. You all saw the slide earlier. All of the species we work with have a long history of non-establishment anywhere in North America. Each line has been reviewed by the FDA under Guidance 187. I want to mention that again. Each line has been reviewed by FDA under Guidance 187, and no lines show any fitness advantage or health difference as compared to their non-fluorescent counterparts. There have been no incidents of harm associated with GloFish sale, and numerous studies have confirmed the initial safety assessment. Fluorescent fish are a low ecological risk from Jeff Hill at the University of Florida, and the idea that the fluorescence trait will not persist in the population and there are no long-term health differences. That was a recent study by Drs. Howard and Muir at Purdue University. And this study was particularly interesting. They set up a bunch of populations of red fluorescent fish. They tracked them over 4 years, 15 generations, with a total of 20,000 fish, roughly. And what they found is that the fluorescence gene was eliminated from the population at essentially the same rate predicted by the net fitness model. And this is important, not only because it validates the net fitness model, but it validates the idea that even if our fish escaped into areas where they were native, the fluorescence gene would be eliminated from the population. The particular issue at hand was that the red fluorescent males they're not as successful at courting the red fluorescent females. So essentially, the red males' mating success is a little bit less. They're not quite as aggressive as the non-fluorescent males. So essentially, they have, forgive the pun, but they have a brighter disposition. They don't reproduce as well. Red gene gets eliminated from the population. So GloFish have been used as a model in a variety of studies, even outside of ecological fitness testing. We have extremely broad public acceptance. Our fish are available in approximately 8,000 retail locations. Consumers' primary concern around our fish is to ensure that the fish are not dyed or injected. They want to know that the fish are born with this color. The sales of dyed and injected fish have been dramatically reduced, and there has been substantial well-being and economic value created. GloFish now underpin a category that drives approximately 10% of all industry sales, and our Clean Water Initiative serves roughly 20,000 people in Kenya. This we're very proud of. This, statistically speaking, will save about 85 lives each year and avoid thousands of people, primarily children, from becoming sick. And this is a great application that we're happy to be able to support by delivering clean and safe drinking water. And Dr. Gong at the National University of Singapore, on a related note, has developed the pollution-detecting fish. GloFish are also widely used in the classroom for all sorts of things, and it is our sincere hope that we have set a good example for a positive use of biotechnology. So looking ahead, as a company, and I think hopefully as a community, our goal is to apply what we've learned more broadly for human and animal welfare. But there is no broad public consensus regarding the ethics of using biotechnology, and that is, of course, I think why we're here today. There is, however, an inherent assumption that only the active use of biotechnology has ethical implications. I think it is very important that we consider the ethical implications of the lack of use of biotechnology as part of any discussion. Moving the biotechnology debate towards a holistic ethical framework that takes into consideration this idea would be very helpful in building a consensus across different stakeholder groups. Such an approach would be particularly helpful for people who influence direction and evaluate potential applications but are often not experts in the field, such as journalists and business leaders. So this may seem a little bit far afield from a conversation about laboratory animals, but as Dr. Kaplan pointed out, what starts in the laboratory, we know firsthand, can often end up in the marketplace. So I think it is very important that this be considered from the beginning. So here are a few quick examples of things that I think we should be pretty urgently considering. So in the area of human welfare, disease eradication through insect modification. I want to be clear, this is not suggesting that we eliminate the insects, just that we help the insects to be immune to the diseases. Diseases like malaria and dengue fever, avian flu resistance in poultry, nutrition support for humans through increased animal disease resistance. So making cattle resistant to sleeping sickness, making goats that produce antimicrobial milk. These things would save millions of lives a year in Africa, for example, and in other parts of the world that are still developing economically. Reducing the use of antibiotics, which can often lead to antibiotic resistance concerns, and then developing organs for replacement purposes, from developing them in animals to provide replacement organs for humans. And then on the animal welfare side, horn-free or polled cattle, sex selection in chickens, and making pigs resistant to African swine fever. And I think at this point, stepping back from these specific examples, I just want to, share my perspective that it seems very clear to me that the tools provided to us by modern biotechnology are among the most powerful antidotes to widespread human and animal suffering that have ever been invented. I firmly believe we have a moral responsibility to urgently consider the ethical implications not only of using these tools, but of not using these tools. These are no longer academic questions. These are vital matters that literally carry life and death consequences with every passing second. I know a lot of us in this room are well aware of this, and that is why we're here. For people who have not been following this debate as closely, I want to mention just one among countless examples. In the time that it has taken me to give this presentation, based on the latest statistics from the World Health Organization, an estimated 10,000 people have become infected with malaria. 23 people have died from malaria. Using technology available today, we likely could have stopped these deaths. These 23 people, including statistically 16 children, would still be alive, and 23 families would not have endured the devastation of these terrible losses. I want to be very clear that I am not saying this to suggest that we simply ignore the potential consequences and just move forward without appropriate oversight with any one particular application of biotechnology or another. But I do want to underscore the idea that inaction has a price too, and that is all too often measured in human and animal suffering and death. It is clear to me that this group has a tremendous ability to influence the discussion. I hope that sharing our experience with GloFish has been helpful. We have done our best to be good stewards of the technology as pioneers in this field, and we will continue to do our best in the future. The questions that I ask today as a humble entrepreneur who simply seeks and sincerely seeks to use the biotechnology tools that we have for the betterment of humans and animals are simple. Are we doing all that we ethically can with the tools that we have available to alleviate human and animal suffering? And as many people before me have asked related to other very urgent questions, if not us, who? And if not now, when? Thank you for your time.